Welcome to Rges, Algebra 2. This is Lesson 30B. I'll begin with the scripture from Psalm 92, verses 1 through 2. And it says, "It is good to give thanks to the Lord, to sing praises to your name, O Most High, to declare your steadfast love in the morning and your faithfulness by night." Now notice four things that were activities that we can do here as we exalt or learn to praise the Lord. We can give thanks, we can sing, we can declare his love and his faithfulness. Okay, and as we learn to do this both in the morning, as we do this in the morning, what it does is it sets our day. We start our day with our focus on the Lord, on his strength, on his goodness, on his character, and not our own. And this is a wonderful place to begin. We remember both. We say this over and over again, but we want to always remember his character, who he is, and what he has done. But I also love this passage because it exhorts us not only to do this in the morning, but to do this at night. Now, I will confess that this is the normal way for me to start my day, but it's not the normal way for me to finish my day. And so I'm thinking about this, and I thought, well, what would be the advantage of that? Certainly he's worthy of praise and acknowledgement all the day long. But I thought, it's almost like wrapping the day, both in the front end and the back end. And in the back end, what I do is I look backwards over my day, and I see that he's been with me. And I think there's great power in this. He's been with me. He's been my encouragement. He's been my strength. Though things might have taken me by surprise, nothing took him by surprise. Though I might have felt like in many things I failed, nevertheless, his love blankets me. His faithfulness still surrounds me. And it's a wonderful way to set your day, okay, rapid, like I say, so that you're not bringing it into the next day. I don't wake up with the failures or the weightiness of yesterday on my shoulders in the morning and take them into my next day. So I love this idea, and I would just commend you to reflect over this passage and see what God might have you do with it also. Now we're going to look at 8.13, our introduction, brief introduction in this book. We get into it much more in your pre-trig, or your trig and your pre-calc, I'm sorry. And then, but we'll look at 8.13, imaginary numbers, and we'll look at the check for progress, and we'll check our answers here. Don't forget that you will be taking a test. I will attach it to the email both on Chapter 8 this coming week. In addition, we'll look at new ideas from 9.1. So go ahead and get your book, get your homework, get everything prepared. Okay, here's the assigned problems, and I've written down our key idea here on the left-hand side. I, standing for, of course, the imaginary, equals the square root of -1, and I squared equals -1. So if we're going to read here our problems, and then we'll come back and I'll give you a few more examples from them. But number 1 is -I, then -1, then I, then -1, then -I, then I, then 1, then -2, then -9, then -12, then -4. That's 1 through 11. Beginning with 12, 9i, 11i, 7i, 6i square root of 3, 9i square root of 2, 4i minus 9i, which the answer is going to be -5i for number 17. Number 18, -120. Next, -30 square root of 3. Next, -72. Next, negative 20 square root of 6. Next, square root of 6. Next, 3i. Number 24. This is where we're going to do some FOILing here. So it'll be 20i minus 25 square root of 6 minus 4i square root of 6 plus 30. Number 25. xyi plus 2xi square root of y plus xi. Number 26. 1/4 plus 1/4 square root of 3 plus 1/4 I square root of 3 minus 3/4 I. Number 27. Oh, I think I did not assign where you have to cube it, just because it takes more time. I think if you got the other idea, you would know how to do it. It's just voluminous and in the time. So the word problems then are at 11%. You should have $3,090, and at 8%, $4,935. For number 30, the length should be 80 feet and the width 50 feet. So let's go back and catch a few of the problems. So what I do here is I substitute I for the square root of -1. Then I'm looking for how many even pairs. So I have I squared to the third power. That would account for 6 of them and one more. Substituting a -1 here. And an I, leave that as an I. Okay. This is going to be negative I. So all of these first ones are like that. Let's go ahead and look at number 11. It says 2 square root of -1 times square root of -4. Now, hopefully this is fine for you, but just notice here that that's the same as I, so we'll convert that here to 2i. A square root of 4 is 2, and -1 is the same as I. And so we're multiplying our i's together and our numbers together, and I squared is the same as a -1. So just take it steady here, and you should be able to, just by using these two definitions, understand these problems. Now let's look at something. How about 13? Again, looking at the number, we've got 3 and -1 under is the same, under the radical is the same as I. And we've got 8i, and we add them together, and you get 11i. For this one, we're going to get 4i minus 3 times, this would be 3i. Right? We're going to multiply those 3's together. Oops. 4i minus 9i, and combining them, we'll get -5i. I might have done that one for you last week. I don't remember. Last lesson. Seems familiar enough. All right, let's see here. How about one more in this group? Let's do 23. Okay, I can't simplify them by themselves, but then you can look at it this way. -27 divided by 3. So that would be -9 under the radical, or 3i. Okay, let's do one of these FOILs for you. We just want to do the first terms. That would be x squared y squared, and ignore the sign for a minute. This will be x squared y squared, which will be pulled out from in front, okay, and the square root of -1, which would be I. That's the first term. The outer term the x will come out, and we'll get a negative y under this radical. So we'll have, let's see, plus x. The negative is going to come out, so that'll be I, the square root of y. Now look at the inner. We have the same thing. The x comes out. We have an I because of this, and a y stays under the radical, so we'll have two of those all together. And now for my last terms, I'm going to have the I because of the negative and x squared, so we'll have an xi, just like that. Sometimes those middle terms will combine and sometimes they won't. Okay, let's look at the word problem. Now that we have the tool of knowing how to do simultaneous equations, word problem setup becomes much easier here, very straightforward. We're going to look for two equations. We've got a part of the money, we'll call that x. X is the part of the money at 11%, and y is the part of the money at 8%. And we altogether, how much money did we invest? 8025, and 0.11 times the x amount plus 0.08 times the y amount ought to give me my interest, and my interest was, or my annual income from the investment, same idea, is going to be $734.70. Now you have a choice here. You can either do these by simultaneous equations, times maybe we'd multiply everything up here by negative 0.11 or negative 0.08, including the right-hand side, or we could solve for x or solve for y and substitution, either one. And again, your answer would be 11%, or my x value. At 11%, we've invested 3090, and at 8%, we've invested 4935. Actually, as I look at these, I think that I actually explained how to do them last time for you. So, for the second one, the length, I remember doing these, is 80 feet, and the width is 50 feet. So refer back to 30A. Now let's go on to our answers for the check for progress. Okay, just 14 here. Recall that a negative exponent means put it in the denominator, so we'll square that 4 and we'll get 1 over 16. A negative in the denominator, we'll move it up to the numerator, and 2 to the third power is 8. So my answer is 8 for number 2, 1 over 16 for number 1. Number 3, my answer is 1. Why? Because anything to the 0 power is 1. For number 4, my answer is 8. Why? Okay. Let's go ahead and do that one. So it's in the denominator of 4, so that's going to be the fourth root of 16, and which is going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, and now the numerator tells me to cube it. So 2 cubed is 8. Number 5, very similar idea here, but don't forget, because of the negative sign, you're going to have to put it in the denominator, and it will be 1 over 243. Number 6, anything to the 0 power is 1, so we'll have 1 plus. Now we're going to square this and put it in the denominator. So this will be 1 and 1/25. 1 plus 1/25, right? So that will be 1 and 1/25. Number 7, Okay, very simple to do when we just have, when we have less number involvement here. Okay, I could take my z to the numerator, and there's nothing to cancel. So the answer, whoops, I'm sorry, without a denominator. So I'll take the y to the numerator also. So you'll get 3x squared y to the negative 2 z cubed. Number 8, you want positive fractional. So remember that square root will make everything to the 1/2 power. So you'll multiply that 4 times 1/2 and you'll get, oh, okay, I'm sorry, and then you're going to do everything to the negative third. Let me go ahead and write that out. The answer should be y to the 3/2 over x to the 6th. Let me do that one for you. So first I'm going to simplify everything within the parentheses, and then I'll do that final exponent. And that's a perfectly good answer, but I need to see what they want me to write, and in this case they want me to write positive fractional exponent, so I've got to convert that to positive, meaning taking it to the denominator. Okay, next one, you should have 5 to this, number 9 should be 5, square root of 5. Again, I'm going to review more than I normally try to because I am trying to use this as your review for your test. First thing I would do is simplify any of these radicals that can simplify. Now remember this last one, we'll rationalize it there by multiplying by the square root of 5 over the square root of 5, keep making no radical in the denominator. So now in order to add or subtract, when we have a fraction, we need to make everything with the same denominator, combining then like terms, and doing our last step, our canceling to simplify, and you're going to get 5, the square root of 5. Make sure, of course, that you would be able to follow this step by step because you're going to have to write it step by step. You can't leave these steps out. I want to see your work. Right? The next one, expanding, we're going to have to do FOIL there, and I think that we've done plenty of that, maybe, hopefully. So ask if you have any more, if you need it, that, repeat it again, but we're going to do a FOIL, right? To get that, so we have 4 terms and we've got to combine. Right? And to multiply then, we'll multiply what's out and we'll take, and then we'll combine what's in. In other words, for number 11, we'll have 3, the square root of 2 times 5, the cubed root of 4. We'll go ahead and multiply what's out. Whoops, I'm sorry. I need to make these the same root first. Let's do the 6th root, right? Okay. So we'll have the 6th root of 2 to the 3rd and the 6th root, so we can combine those, of that would be 2 squared, and now we've got to square that 2 to the 4th. And so we've got altogether 7, so we'll bring it forward. One of the two, 6 of them, I'm sorry. We'll bring it forward 6 of them, and so that'll get 30. And then underneath the radical, we'll have 1 left over. And the radical will be the 6th. Whoops, not there. We'll have a 2 left over, and it's the index is 6. All right, so that's the answer for number 12. Number 13, we rationalize the denominator. Now this time, remember, it's with the conjugate. We're going to distribute our 6 in the numerator. And we'll get 12 plus 6 square root of 3. And in the denominator, we'll have to do FOIL. My first term will be 4. Minus and plus, the middle terms drop out, which is why we choose this. Right? Same terms with the opposite side. And then it'd be 4 for the first term minus and 3 for the last terms. So that would just be over 1. We can kind of ignore this, of course. And that's my answer there. Number 13. Okay, the easiest way to compare these two values is without using a calculator is going to be to convert them to the common root. The common index, which is 6. So this was 2, so we'll cube it here, and this will have to square it, and that would be 8, and that would be 9, and so which would be larger? Okay. Simply finding the same index. And finally, solve for y. The square root of y squared minus 8 plus y equals 8. Now remember, to solve, when we have an equal sign, we're going to need to isolate a radical, square both sides, and if you have a second radical, isolate it again. But we only have one, so we'll take that y to the other side. We are going to, by subtracting, right, we're going to square both sides. So this will leave me with y squared minus 8. Don't forget you got a FOIL. So this will be 64 minus 16y plus y squared. We're going to simplify. Now, what I would recommend is that you glance through each section, except for anything we might have skipped. I know we skipped 8.14, but glance through every section and make sure that you can do all the problems on Check for Progress without a mistake. And if you can do that, then you probably will be fine for the test. Again, I will want this test done by next Monday. You can either mail it in directly or you can hold it in a folder until you're ready to mail some things in, but definitely have it finished. I would recommend with math that you go ahead and mail them in on the shorter side so I can address any issues before we get too far away from this. Now on the next page then we're going to go ahead and start the new idea, which will be 9.1. Okay, for our new concept here, we're in a new chapter. It's called Quadratic and Higher Equations. And recall, a quadratic equation has an x squared term as our highest term. So x squared plus 3x minus 2, that would be an example of a quadratic equation. Now the first thing you want to do, so we'll be in this first section, we're going to just look at how to graph quadratic equations and determine where the graph intersects the x-axis. Now there's going to be, so the graph will be something like, it's going to be a parabola. It might be there where it touches in one point, or it might be there where it has 2 points of intersection on the x-axis. So 3 options. This one has imaginary roots. Okay. Remember our I. Okay. This one has one real root. It's obvious it's one. It touches the axis in one place. Real root. And this one has 2 real roots. So you are going to first set your equation to 0. It means it has to be equal to 0 if it's not already done so in that form. And then you're going to make a table, a graphing table, plugging in values for x and determining your y, plotting it, and deciding which of these three options you'll get, and then reading off the x intercepts. Okay, so let me do one for you here. This will be number 1. You're going to have just 1 through 15 odd. That's all you have to do. Okay, so number 1 says x squared plus x minus 2 equals 0. It's already set to 0, so we're fine. We're going to kind of ignore this part and instead set it equal to y. Just like that. Okay, so now we can make our table. For values of x, what would the y be? So let's say I have 0, let's say 1 and negative 1. These are just going to be, remember these things are arbitrary. And 2 and negative 2, that should be good enough. And maybe I'll even do 3. Plugging those in, I'm going to get negative 2. For number 1, if I plug in 1, I'll get 1 plus 1, 2 minus 2, that will be 0. For negative 1, I'll get 1 minus 1 is 0, minus 2 is negative 2. You see what I'm doing? I'm just taking each one of these and plugging it back up here in the equation. We've done this a long time ago. Okay, so that'd be 4 plus 2, that'd be 6 minus 2, or 4. Wait a minute here.